Okay, today we're going to be looking at CD player repair. I've got a Sony here, quite a common type of CD player they made a lot of from the, I'm not sure when they really are, mid to late 90s I think. CDP 295 is this particular one, but a lot of these CD players, even going back to the late 80s and early 90s, end up using these sort of Sony type mechanisms. So this is one a bit earlier one I think, because it's got a KSS 213, but it's actually a KSS with the long connector there. Some of the early ones, like this, is a 212, which was quite a rare one. The early ones had these two connectors, red and white ones normally, but all this KSS series were, I believe Sony actually made the mechanisms, but I don't think there's anything on them that actually says they're Sony's, but the parts are always listed as Sony ones. So these are a very common sort of mech. Basically the spin motor, the laser, here's a KSS something or other. These were, I forget, what were they, 240s I think, KSS 240s. I guess I'll have to have a look. Oh, you can see it, yeah, it's a KSS 240A. Was a very common one in the Sonys. And a couple of gears, which are run by another little motor here, so there's two motors. But there's all sorts of different mechs used in different brands. Some generic types, like these Sony ones, are in a lot of different things. While other manufacturers, some of the more high-end ones had their own. Philips had a different, like a laser that swung on a sort of arc. I think Technics and Panasonic used their own mechs and different lasers and stuff. Few odd things, like some of the Pioneers had the laser upside down, and often the lens used to fall off them onto a disc, which seemed to be a common thing. They had really terribly annoying lasers to set up and realign. These sort of mechs are luckily more common and very simple to work on. If you want to know the full story of how a CD player works, there's no point me reinventing the wheel and describing the whole system, how it operates. There is a channel called, I think, Technology Connections. I'll hopefully put a link to that video. And he does a good job, might even be a couple of videos, but he does a good job of explaining how the system works. But basically it's fairly simple as far as the repair side of things go. You don't need to know the full details, but basically you've got the disc, obviously. This is the underside of it with the reflective side there. And the laser reads that. As most people probably know, there's a laser in this which reads it. And it starts at the centre and works its way out. The actual speed changes because these tracks are a certain length. They get longer and longer as they get further out. So basically, to read the same amount of length of track in the same time, they've got to run it faster at the beginning, and it slows down. The actual motor spinning, it slows down as it gets out to the outer part of the disc. Basically the laser itself, the little pickup unit, laser pickup as it's called, because it's got the laser. That's the lens on the top there. The actual laser itself is mounted in the side here. It's this little brass piece here. A lot of them have like a brass coloured housing on the laser because it gets quite hot. I've got 3 pins on these. I'm not sure why it has the 3, but it's basically an LED type setup. Most of them have a little laser power setting on here, a little trim pot, which generally you shouldn't touch unless you've got a really dodgy laser that's on its last legs and you want to try and get it going a bit more. You can actually tweak that up a bit. I think normally you try and do it with the power off and don't move it too much at a time, or you can blow the laser supposedly. So there's a power supply on the main board of the CD player that runs that, and that's basically just like a constant current source or whatever that just runs the same all the time. There's a little prism inside here. You'll notice the lens is up here, lasers going in at that on the side there. So there's a little triangular, like it's actually a cube of glass, but with like 2 triangle pieces stuck together, I think, from memory, and that gives it like a face inside the glass cube that acts like a prism. So basically the laser can go in, hits that angle piece of glass, bounces up, shoots out this little lens here onto our tracks on the disc, and then they reflect the laser beam back down through the same lens, and it comes down straight through the prism. It goes through it, doesn't reflect off to the side like the laser. And it goes to this little set of, I think it's 4 photodiodes on the bottom here. Looks like a little IC and a little clear case. Well, this one's sort of tinted a bit brown, but they've all got the same sort of thing. This is clear. You can actually see the sort of elements in there. Probably one big common earth connection in the middle, that big bit of silver. and then we've got multiple little diodes going onto that, and almost looks like there might be something else in there. There's a couple of extra connections there, but these are photodiodes, so they just pick up the LED light or laser light, bounce back. And the idea of those is you've got a grid of 4 of them, so they can actually set the focus. They can detect by the amount of light falling on each one, or the shape of the light, which sort of is the same thing, how much it falls on the different things. That determines if the lens is actually in focus, because this lens goes up and down, which we'll show in a minute. And it also helps with the tracking, because as the laser follows the track on the disc, being a spiral thing, much like a record, it spirals round and round, so it has to follow it, and they obviously get to one side as it's following the groove, and that can show on the laser, on the diodes, that the laser's actually moving to the end of the travel, because it's also, the lens can move sideways in these things. It sort of pivots, I think, and then once it's moved to the end of its range, you've obviously got to use this little gear and assembly to move the whole sled, as they call it, because it slides back and forwards. So there's that motor to be controlled, but that's all done in the chips in the player. It's all servo. Basically, there's something that reads that those 4 photodiodes come back into here somewhere to be processed, and some of the signals coming out of one of these big sort of postage stamp chips under the board will go to some other driver chips that run the actual motors, and also the laser. If we pop the little cover off these, that one doesn't really want to come off. They're often held on reasonably well, but they're only clipped on. Just a little plastic cover. And once we get in here, you can actually see a couple of these red coils of wire. They're much like voice coils in a speaker. There's a couple of little magnets, one there and one there. Stick it to my screwdriver. And so much like a speaker voice coil, you've got permanent magnets and some coils of wire, which if you put a current through them, through the normal electromagnetic principles, that will actually cause them to move, because the magnetic field in the coil versus the magnetic field in the magnet. And this little assembly here can go up and down. It's just pivoted on this bit of plastic. There's a couple of little pins there, and so the lens can get closer and further away from the disc to find a focal point, which probably is pretty similar in most discs, but of course there's a slight difference, I guess, with at these microscopic levels, where the actual aluminium, because that's an aluminium layer in there that reflects with the pits and grooves or whatever it has, or pits and, I don't know if it's just long pits and short pits or dots, sort of like Morse code, or whether it's actually just pits and non-pits, but they're basically a little pattern that produces zeros and ones digitally. So this has to focus up to that layer in the disc and get it in the right sort of focus. The other problem is, of course, when the disc is spinning, it's slightly eccentric, so that disc is actually wobbling back and forwards like that, and the laser's got to follow it. Underneath, it's going up and down slightly. No matter how good the motor and platter and everything is, there's a slight wobble in them. And maybe even the aluminium inside this, I think they just drop some like epoxy resin or plastic or whatever it is onto these things and spin it. So the foil itself probably isn't perfect, not at the sort of level these things work at. And the other thing this can do is just, again, using the current in these coils, the DC offset, it can sort of pivot to one side or the other. So as the disc is going along, the focus will be going up and down, there'll be a DC signal coming back from the processing chip via the signal in those diodes. It'll be saying, well, I'm not quite focused, so that'll put a bias on this to move it up or down as needed, and often they'll sort of travel up and down with the disc, since the disc is constantly spinning. And then as it follows the track, it'll actually tilt to one side or the other, until, like I say, it will start putting so much signal. 2 diodes won't get much and the others will get a lot, and it'll know it's time to kick the motor in and move the whole sled assembly slightly to one side. This actually has 2 gears, a little sprung bit, but not exactly sure why they do that. Maybe just to allow that to, I'm not sure if it puts a bit of tension on there. I guess that's one thing I should actually look into, is why do they need that. But I think it's more just as the motor turns, it can slightly move under the spring pressure before actually fully moving. It's something like that, just to make it a slightly finer control, I think. But generally, I don't think I've ever had trouble with these actual this part of the gear. Some of them will have this one. Basically, they'd be mounted on a metal piece like this. So this little metal shaft that the laser slides on. The other side just sits on this little plastic bit here. It's just got a little groove there, so it literally just sits there, just sort of under gravity, just slides along. Some players will have two of those sliding bars, one each side. But that's the main setup. Like I say, the Philips ones, and possibly some of the, I'm not sure if Technics or someone used them as well. I think someone else did use them. They have a sort of, the laser pivots on an arc, and that uses like a voice coil type set up to actually pivot the laser across rather than having this motor that creeps it along. So I think it's basically the laser has the same principle, the moving coils in there, but instead of having a motor that eventually kicks it along and slides it along to follow the disc, they actually have like a voice coil. It's a bit more proportional. You can sort of control it a lot better, I would think, and probably a bit smoother. But to be fair, these mechanisms work perfectly well as well. I'm not sure there was any real increased performance from that type of design, and it was only Philips and maybe one other company that used it, I think, so it never really took off. So basically that's sort of the main part of this. You've got obviously the spin motor. Now the process with which these things work is when we load a disc in, the tray will hit a switch, and in most players, probably all of them, if this laser's back out here, it'll come into the center. Probably should move that gear. This one's actually got a cover on it, doesn't really help. It'll center itself. Even if they're in the center, a lot of them, there's a little switch. This one doesn't have it on here. A little switch will press to say the laser's centered, but even then most of them will tend to flick it back a little bit so the switch goes off and then flick it back in again. And as soon as it gets into the center, it'll start, the lens will start going up and down, the laser will come on, lens will start going up and down, and it'll start looking to try and focus on a disc. If there's no disc in there, it'll just go up and down a few times, and then it'll basically give up, often with a little movement of the motor again, a little recentering. If it finds a disc, that's when it'll actually start the spin motor up and actually start trying to read data off the disc. So first it has to focus and check there is a disc in there, make sure I can get it in focus, then it actually spins it, and it starts looking for the table of contents. It'll start moving either the coils or the actual motor here, trying to find the inner grooves as such, the inner pits on the disc, and try and read something off it, so it knows it can actually read it and what sort of disc it is, where the tracks. I think it gives it the information of roughly where the tracks are spaced. If you've got multiple music tracks, so when you fast forward or skip to the next track, as it is with these, it knows roughly where to go, so it'll spin the motor quite quickly, and then it'll have to do a bit of fine tuning to find the next track, and then once it's read the data, or I think there's something to indicate it's the beginning of the track, it'll then start playing that one. So like I say, at the beginning here, this spin motor will have to run faster, and as we read more of the disc and we get out to the later tracks, it comes right out to the back here, and it'll actually slow down considerably compared to what it was. I've done some video of some close-ups of this and make it a bit easier to see what's going on, because you can't really see anything with the disc rotating. And eventually it'll just run, I think it just runs out of data or reads the end of the disc. There's not normally any sort of switch on the end of these, like a limit switch, so before this fully gets to the end of the gear, it'll detect the end of the disc, the data's run out, and it'll just come straight back into the center, which is that noise you hear when a disc ends, and it'll sit there. So this one's got a little dust cover on it to keep the dust out of it. So to clean these actual lasers, it's always the first thing you should do with any faulty CD player, or even just as routine maintenance. Really just need some alcohol, metho, anything on a cotton bud. And if that lens doesn't look, they'll have a bit of a shine, but if they're not really shiny, then they're probably dirty. This one looks like it's got a little bit of dust on it. Yeah, that's definitely, some of it's probably the liquid, but that's shined up quite a bit. I'll just dry that off here. Much shinier than it was. You often see a slight brown stain on there. It can be dust, can be cigarette smoke, wood heater smoke, all that sort of stuff. We'll put a fine layer on it. So if you've got one that's not playing properly, always best to clean that. And any time you try and fix one, it's always the first thing you do. Second thing would normally be to lube. Put a little bit of light oil or light grease on this bar, or on both of them if it has two. Normally you don't really need to do the gears. You can put a little bit of fresh grease on the geared bit here, which will get back onto these teeth. Occasionally these gears will break, that it should just squeeze in and pop out, which is nice and simple. If I can squeeze them together enough, this gear should just come upwards, which is going to make a liar out of me. I think it's going to break before it comes off at this rate. There we go. And you'll find these inner teeth that run along the black bit on the side of the laser, sometimes they can get a bit chewed up. They can get some sort of like gritty stuff in there, build up a dust even, or they'll actually break right off or quite a bit off. And to look at them, you can see they're pretty bad. And when you try and run this through just by hand like this, you can actually feel that it's pretty crunchy and horrible. I've had it a few times, but pretty rare, so it's not a big thing. These spin motors like this one, especially in these Sony mechs, some of the sharp ones use them as well with these really long shafts. I think they're 43mm from top to the back of the motor is how you measure them. Most of them were, what were they? They were these RF310 motors. There's a couple of spare ones I sell, which I don't think they're new ones, those now they've been soldered. A lot of them use these RF series motors, and if it's the big long one, they were common, especially in the Sony players, as well as ones that use the mechs out of them. These long shafts for causing the disc to skip, just because you couldn't really tell. You could spin them and they seemed pretty normal, but there must have been a bit of vibration or some sort of play in them, eccentricity or something, and that would be a common thing. I've seen it in a couple of sharps, but these Sony mechs, I've probably changed dozens of them. Quite common for causing skipping problems, so just that little bit of mechanical vibration can be enough. They also have little rubber mounts in the corner normally, so that the deck is mechanically free, much like a turntable. The old record players usually have springs that they sat on, and they can go hard as well. If they're really hard, that can cause skipping problems, especially if there's any vibration. It'll go straight through into the mech, so anything like that, any sort of eccentricity, even these, if you get dirt build up on the platter or the clamp bit that sits on top of it, this bit here, I always used to give them a clean as one of the first things I did as well. So give it a lube, clean the laser, clean off this platter bit, mainly the thicker bits or the higher bits where the disc sits, and even this central bit doesn't hurt, that usually presses down. This one doesn't. Some of them are flexible. Yeah, this one here on this mech, which is similar to this Sony, that actually presses up and down. And they got this sort of metal platter. These are common. They got this sort of plasticky stuff on them, so always give that a clean to remove anything stuck to that, because that adds more eccentricity to the disc if it's sitting slightly tilted and sort of going up and down a lot more. It makes the laser work harder. Anything that makes it work harder is more likely to cause problems. Don't think I've ever had one of these sled motors actually fail. Be pretty rare, I think, but I'm surprised they don't cause some sort of problems. But they're not as precision as the spin motor, don't affect the disc as much, and I think the laser and the gears can sort of just make up for any small problems in those. I don't think I've ever had one that didn't run or was bad bearings or anything. Now another thing, so when you put a disc in, or load the player without a disc, you'll see it go through its little, the laser will flick up and down. The laser itself, you don't ever want to look into that, because it is an infrared laser. I think it's not that visible. What does it say? Class 1 laser product. Whatever that means exactly, but you should never look directly down into the laser. So always be careful on a CD player to work from the side of it and look down at sort of 45 degrees. Never have the mechanism facing towards your eyes. Just because as soon as you power that up, it'll start hunting, looking for a disc. And yeah, potentially could damage your retina or something if it gets directly in your eye. What I normally do is sort of look around 45 degree into it, and when it does fire up, you should be able to just make out a little, like a red LED in there, just a little red bit of light. I don't think I've ever had one that didn't light up. Some of the early players, supposedly the lasers would go in them, but normally when these lasers play up, they're just low power or something like that. They'll still light up, they'll do their focus search, and they will find the disc. The other test is just, yeah, if it doesn't seem to do anything, just flick this out, and as soon as the tray loads in, this should come spinning back down and look and sort of bounce off the center a bit. Often they come right in and back a little bit, and then the lens should start going up and down looking for the disc. Again, very rare you'd ever find any problems with that side of the player. Possibly if a motor drive chip has been blown up. I think I had one that someone had switched it from 240 volts to 110 volts and plugged it into 240 volts, and it blew all sorts of things in the unit, and one of them was the driver chip in the CD player, so I think the CD wouldn't do anything. None of these motors would operate. I think that's the only time I've ever had a problem. Most CD players, you'll find as soon as you load it up, you'll be able to make out that the laser come on looking at it from an angle. You'll see the light come on, you'll see the focus search happen, and you'll also get these motors, if you wind them out, they'll come back to the centre, bounce off, and then start doing the focus search. And then the next step would normally be, if there's a disc in there, obviously with no disc it just gives up because it can't focus on anything, there's no light being bounced back into it. But if it finds light bounce back into it, the next step will be to try and spin the spin motor. Again, normally these things always work, but they may not be as good as they should be. Some CD players you'll find, you'll hear that's making a bit of a funny noise, the disc isn't spinning, maybe it doesn't spin at all. So what you can do sometimes is just give it a manual spin on top of the clamp, if assuming the whole mechanism's still in there, and often that'll get them running. And that's not actually a problem with a spin motor, that's normally something to do with the settings or the lasers on its way out. Or often you can adjust some settings for focus gain, tracking gain, and a couple other offsets or biases or whatever they are. Some have an EF balance control, different things. And often by tweaking the pots in the thing you can actually get it to work again. Nothing to do with the actual spin motor. Like I say, the only problem I've ever had with spin motors is them causing the disc to read badly. They'll still run, the player will work. It seems like it's got a dodgy laser or something because it's skipping and carrying on, but it's actually, it must be some sort of vibration coming out of the motor. It seems to be running fine at normal speed. If you feel it just by spinning it, holding it in your hand and spinning it, it seems fine. Maybe feels just a little bit like it's got a little bit more vibration in it. But generally these mechanisms, so you can either change the laser in these if the laser's faulty, you can change the motor, and you can also, at one stage, you could quite cheaply buy the whole mechanism with a whole new motor, laser, gears, everything. What spare parts are like these days I'm not so sure, probably not so easy to get. But normally if you order a laser pickup, you just get this little laser part, put the cover back on that. So that's basically what you get when you order a laser pickup. Just comes as this unit. Most of them will have like a couple of little pads on this one, little silver pads on the corner of the board there. They'll be soldered together, there'll be a solder bridge over those, and that's actually across the laser to short it out so that static electricity can't get to it. You should really have a static wrist strap and stuff on when you touch these things. I haven't worried about it too much, they're normally pretty reliable. Don't seem to be worried about static, but if you've got sort of synthetic clothing or anything, be extra careful. And when you get one of these brand new, you need to unsolder that. Just get your soldering iron and suck the solder off with the tip of the iron, rub it across, and separate those two pads so that the power can get through the laser. I'm not sure if it actually damages anything. If you don't, it's possible it could damage the laser power supply, but I don't think I've ever put one in and forgotten to do that. But most of them will come with some sort of bridging thing there, so that's something else to look out for if you ever change a laser for a new one. You can easily just salvage these out of second-hand things if you've got some, if it's the same type number, same connectors on it, and always get a second-hand laser out of a similar model or something and get them going that way if you can't find new ones anymore. So that's always another option. But that, bad lasers will cause not able to read the disc at all, or poor reading of the disc. I don't think I've ever had one that necessarily doesn't even try to read the disc, but normally they just won't play very well if the laser's down in power and stuff. But of course there's other things that can cause those problems as well. But that's basically most of these modern mechanisms. They're as simple as you may have to take that, I think I have to take that gear out again, pop that out, that'll make your laser free on this metal bar, and this just has a little simple mechanism there that you press a little white piece inwards and then the metal bar slides out. Obviously if they've got two of them you've got to take them both out and your laser's free. Obviously it would have a connector normally, but if you've already disconnected that to get this mechanism out, and it's just a matter of sitting the other one in, slot that little piece onto the plastic side here, sit it roughly in place, and you just simply slide the bar back in. These are really brilliant, these little mechanisms, nice and simple to work on, and just get that to slide on. and you'll just need a screwdriver or something to push that right through. And that's loose. You put a little bit more lube on there, either now or after you put the gear back in. That just clips back in, and there's no more real alignment or anything to do with that mechanically. That'll simply sort itself out. You may have to do some electrical alignment, but you probably already had a check of that to diagnose that the laser was faulty anyway. So I might actually pull the actual player here apart and show you what needs to be done. Now, most of these, the problem with them is you need to be able to power up the player, and so I've already got the screws out of this one, but you can't actually pull the mechanism out because you've got a door on the front. So I'll just put that back into its position. So a lot of them you need to power them up and get the actual tray to come out, and most of them you can just press from below, just push the bottom of the door out a bit and push upwards, and that just slides off. It's just got a couple of little bits that clip on there, either and they catch on the front, or this one's got the bits on, a couple of bits sticking out on the door, so they just need to be pushed out a bit so they can get past what they catch on, and that just comes off. Normally you then load the tray back in, turn the power off, and we can get the deck out. Obviously there's 3 screws, normally one each side and one at the back. I've already had these out because I was filming it, actually reading a disc. Usually there's something like an edge connector, and you can just pull that out, get the player out of the way. And actually with this one we probably should have ejected it first. See, often these eject motors are hidden down here. Once you get it out you can actually get to the gears, but unfortunately when it's in the player that's often not the case, and the door's stopping it doing anything. These have a funny design, these ones. I don't know if I can actually wind that by hand. It's going. Sometimes you can actually wind them with a screwdriver or something, and this will be, it's actually dropping the mechanism down now, which is another part of these. The actual mechanism itself, because you've got to clamp the disc between this bit on the top here, the clamp part, they've all got some sort of arm. Sometimes these pieces come off. This one's, I think, largely moulded to it. You could probably, you can actually get it out if you really want to. Sometimes there's a couple of screws here and you can take that bit off, but they've all got some sort of clamp part, and of course you've got the actual disc platter part here. So in order to load a disc in, the disc basically has to come, this part will drop down, and the disc comes in on the tray, and then it lifts the mech back up so that the actual platter part and the laser and everything then fits through the disc and presses against the top part, the clamp part. I don't think any of them, or maybe some of the top loads and that, the door used to come down and you'd have the clamp on the door part, which is why I think they made a lot of them front load and top load at first, until they realised you could actually just swing this part down, so the clamp's always fixed, and this part pivots up and down. So that's part of the loading mechanism. Again, you've got usual sort of problems with these are just like usually a belt. This one's got a belt coming from this motor over here on this circuit board across here to another gear. Bit hard to see. To get that out, you often got to take the clamp part off and take the tray out. Then it's really just a matter of aligning them back up, which isn't too hard normally. And so that is basically this motor here, which also has a switch on it. It's actually got 2 switches on it, I think. Depends how they do it. But there'll be a switch for when it's reached the end coming out, and also another switch for when it's reached the end going in. And that'll also make this laser mechanism part lift up and down. So once the tray's gone in and the disc is sitting above the platter, it can then lift the whole mechanism up. That'll clamp it, and then the laser will come on and it'll look for the disc. If it finds one, it'll then spin it up and start trying to read it. So that's the normal process. These are quite simple. These Sony, I normally get them into the down position when the tray's out type of thing, because it brings the mech down on this gear here so that the pin's at the bottom. And then it's as simple as one little screw here, and we can basically, it's still got a bit of plastic around it, but we're almost right down to the basic mechanism. You just pull one side up, slide this other pin across, and then you've got to pull the pin out of the loading part there. This has got another connector on it, which I can just loosen off for now. That can actually come out of the board here. And we can get rid of that bit. So we can remove this mechanism, take the 4 screws out, and there we've got our springs. These don't actually have much rubber around them, it's only on the top here that between the screw or the plastic mount here goes up inside there, and the screw sits on top, so you've got a bit of rubber isolation. And the springs, these all look to be in good condition. Normally these springs here just pull off. They sort of tend to glue themselves to that. To put it back together, you can just shove them on the plastic bit, screw that back together. Now I've got the old bar that holds the laser in sticking out there when I've removed it. Now these are actually height critical. You should always put the platter back in at the same height as it was. What I used to do, you can use like vernier calipers or something to get that height, either between the mech and that, or the bottom of the motor. Technically you could measure it with something. You could maybe mark something that fits in there, or find something that fits that gap. I used to actually have a screwdriver, I think, that I used to have a mark on, that I actually jammed between, even though it's on a bit of a ramp, without push. That motor has a little bit of upwards play, but you could actually just set it to that, because that was actually convenient for, you could push the motor down until it hit that point on the screwdriver. But all you need to do to remove these platters, they're basically just press fit, and you can shove a screwdriver under them some of the way. Often use something like a pair of big side cutters, and you just keep pushing against the actual deck, and then you can pull that off. And then it's just a matter of taking these 2 little screws out here, and if you've taken the circuit board off already, that motor will come out. And they do have a positive and negative terminal. Yeah, it's got spin, SP, plus and minus. I think if we look at one of these RF motors, yeah, you've got a red dot on the positive side. So again, make sure, often I think I'll just put a black mark or something there from the motor to the chassis, just so I know what the orientation was before I take it right out. I think the label's also an indicator of which side the label goes on. Is usually pretty accurate, although to be honest, this one's got the negative on that side marked on the board, and this has got the negative on the other side going by the label, so that's not a reliable thing. Made in Taiwan. Yeah, all this RF310 series. I think the ones, oh yeah, the RF310T as well for the other little motors that run the sled. Is it Mabuchi or something they're called? They used to make cassette player motors as well. Something like that. Yeah, Mabuchi I think it is. But these ones did play up a bit. So basically just unscrew that motor, again making sure you get the positive and negative right, put the new one in, and then it's just a matter of putting the screws back in. And normally before I put the circuit board back on, there goes another spring. You've then got to reinstall this part, obviously. So you've got to be careful when you put this on. It'll suddenly, you can press it a bit, but it may suddenly shoot down. This one's actually quite good. But I used to have a screwdriver, just set to the right thing, set it in place, and you just push that home and it would hit the screwdriver and stop at exactly the right height. Because I used to do quite a few of these and they're all the same, that's how I did it. But ideally you should get the height. It doesn't have to be perfect because the laser has a bit of range for the focus. Obviously they would have set this, I guess, to get the focus in the middle of its range, so it's not right at one end and struggling. But basically the bottom of that platter bit sits just below the top of the screws. There's another way if you just went past that ever so slightly. I don't know how much below that is, probably like 0.5 millimeter. It's not a lot, but it's as simple as that. And you've got a mechanism that works. Again, that one's actually not sounding the best, probably because it hasn't been used in a long time. Maybe that motor is a bit iffy. And generally you wouldn't have to do much else with these. They do have a couple of adjustments there. This Sony one's a bit annoying because they're right underneath the, most of them have them on the circuit boards, these have them underneath here, but normally you didn't have to touch them much. They either seem to work or not work. But it just says, oh, that's just the RV, that's just the trim pot number, I'm not sure. And I know these Sony lasers in these things, if you look on the back of these KSS 240s, they've actually got a set of pots on them. One's there tracking balance, which is TB, FB, which is focus, balance, I think. Is it balance or bias? Balance, I think. And APC, I'm not sure. Some sort of gain or something. I forget what that one actually was. Actually got a little electrolytic capacitor on there, I guess could go 40, a little tantalum cap, a transistor. So they've actually incorporated some of the stuff onto the actual laser in these ones. Whereas the early ones, there's basically just a trim pot for laser power, and everything else goes back to the, and then just your laser and photo diodes, everything. Oh, there's one, I lie, there's one capacitor or resistor there. The rest of it's all on the actual main circuit board. These ones, they sort of incorporated it so they could do some of the processing right on the board here. So I think these actually process a reasonable amount of the laser. I get a feeling they might even have the RO underneath their labels. That's good. The pot, that's focus gain, FG. Where's the other one? Oh, there. Tracking gain. So tracking gain, focus gain, and they're the balance or bias. I think they balance on the laser at the KSS. Where is it? There, 240. Not really sure what the APC is. It's something. I think it's APC. It's a bit hard to see with that label someone's written on it. But normally you'll find gain and balance controls or bias controls. And then we've got various signals going back here by the look of it to the other servo. It's probably more just a servo chip in this one. This is probably the first part of the signal processing. And then you'd have your D to A converters and stuff, because obviously it's a digital signal coming off the laser, and part of it's split off to basically control the motors and the focus and everything, and the other part is obviously eventually converted into analog audio. You generally don't get problems with these little switches that detect the lasers come into the center. I don't know if I can easily see that in this one, but there is a little leaf switch just under the metal bar there. It's probably easy to see on this one if it's got it. Yeah, there it is down in there. There is just a metal leaf switch, and when that laser comes into the center, it just presses that, and often it knows it's centered, and then it can start looking for the actual data off the disc, or it has to do that before it even switches the laser on, and then focuses. Then it spins it up and tries to read it. But they're quite simple to change, most of these lasers. There's nothing too complicated to it. They come factory sort of preset. All those little pots there have all been set. Supposedly these KSS 240s, I don't think you're meant to touch them. I think on a couple of occasions I may have tweaked them a bit to try and get an old laser going, but generally with these, if they don't work, it's needs a new laser in it if they're reading badly, and it's not the spin motor. If you're doing one for a customer, usually best to change the spin motor if you do the laser anyway, or that's why they used to sell you this whole mech, I think. Or if you weren't sure whether it was the laser or the spin motor, or if it's, you know, looks like it's had a lot of use, sometimes it's better just to quote for the whole piece and just swap the whole thing. Basically just a matter of mechanically mounting it, soldering that circuit board back onto the motors, plugging in the laser, and away you go again. They weren't that expensive, around $50 I think, but even the laser on its own was $30 or something. So a fair bit of that price, and at least you then got a whole set of new parts, and you could be sure it was all going to work. But the majority of these, I had quite tons of them. I did just had to change the motor, and like it's a $10 motor or whatever, and it was cheaper just to do that, and wasn't that big a job. Once you get used to doing them, they're quite simple. And yeah, so put the laser in. You normally these newer ones, you don't really need to adjust anything. There is the pots there. I think you can actually get to them from under the board if need be, if you've got a fine enough little screwdriver. Often another thing you don't want to do is put metal screwdrivers in these, like the little jeweler's screwdrivers, which I have one around here somewhere. One of these things, because when you're actually touching this metal, you're putting like 50 hertz hum and stuff up there, and while it'll fit in that pot and tweak it, it'll often make the servo circuit go silly, and the thing will stop reading the disc, or the laser will start vibrating or doing something weird. So normally you need a plastic or ceramic tool to do that, because you're basically touching the metal part of the pot, which is the wiper of the pot, so you're actually putting like a 50 hertz hum into there, and they're not very happy about that. But they can be adjusted on this. Most of them have on the main board, so you can just run the mechanism and adjust them from there. And we'll have a look at a TAC player later on where I actually do that. They were a common one for needing adjustments. The earlier Sony type mechs with the KSS 213s and stuff, you could often tweak them up and get them working again just by adjusting them, and I'll show you how to do that. You can actually, this should have an RF thing here somewhere, a test point. They certainly made them a bit harder to find in these later ones, but you can look at the I signal, as they call it. There's a pattern that comes off the sort of RF signal that's reading off the disc. But I found that often wasn't very useful. The oscilloscope had trouble locking onto it, and it really didn't look that difference when you were tweaking the thing. So I just came up with a different method of doing it, that you don't really need any test equipment, just a bad disc. But no, I can't find the RF. There's an R something there. There's some sort of point there, but usually there'll be some sort of test point on the earlier players with everything on the main board. There would usually be either a wire link across the board, or a little pin sticking up, or a little connector. But that's something we don't need to worry about in this one. So we can put that Sony back together. This other deck that I had apart, just see if any of the springs fall off, you just sit them back on there, and you can put that back on its little plastic bit there. Actually, do I need to get the board under? What have I done here? That doesn't help, having that in the way. Sometimes those connectors get in the way a bit. Just get all those lined up. And the little screw bits come back through these holes in the rubber. And it always pays to just make sure they're sitting on there properly, those bits of rubber. Sometimes they fold up or they stick down or something. Make sure they can slide back up to the ends okay. And these don't like it when you sit them down like that. As soon as you sit them down, they push back through. But just tighten up the screws again, making sure you're pressing down, because otherwise you can get that rubber pinched. The screw should come down until it hits the plastic, and then the rubber should sort of sit below that freely, because these wheels sometimes get over the top of the plastic and then you damage it with a screw. You can tear them easily, so you just got to be a little bit careful. I'll put that back together for now. That can go back in the parts bin in case I ever need anything off it. I don't think these Sony ones I've ever had to do anything other than change the motor, or the spin motor, that is, or the laser. Both of them gave a bit of trouble in these, especially when they'd had high hours, lots of use. So I'll toss that one to the side, put that motor back in its bag. I think I just salvaged a few motors out of some old ones, because I was using, this is one of my CD players that I had as a spare, and I did have a 5-disc player, so I kept a few parts just in case I ever had any trouble with my one, but I haven't used them for years now anyway, because you can use it on the computer these days through iTunes and that sort of thing. Now, to get these back in, you've got the pin that goes into the loading part to pivot up and down, and these other two pins, one which the screw sits on, but the other one has to slide in. I think I normally shove that into this gear part here. You can see there's a slot made for it which starts sloping up to lift it up. So if you've got this in the eject position, you can also actually see the belt down in there, hopefully. There is a rubber belt. Looks like this one you've got to take the gears off. So this tray, often these trays can slide out without having to remove the clamp. You've just got to work out how. I must admit I forget with these Sonys. Do you have to remove the clamp, or is there something else? There's usually some little plastic piece you move out of the way. Not on the back, so the back of these can't actually move forward fully, I don't think. I don't know what that, so something's hitting the switch. Something's hitting on that little tab there. I don't think I've pulled many of these trays out of these Sonys. I'm not sure if I've ever changed a belt in one, so I think this one you've got to unclip this. There's a couple of pins here that lift the clamping mechanism. I won't mess with that in this one. It's a matter of working it out, and you may have to pop a gear off or something, because the pulley on the motor's free, but there's another gear in the way, so that would have to be lifted up. That may just slide off, and then you can just change the belt. A fairly simple job, but to get this mech back in, we put the pin in first into the part that lifts it, and then you just swing it slightly to one side so that this other pin that locks sort of underneath, slots in. Just slide that in underneath this bit of plastic, and the other one should just drop straight in. They're all got some sort of similar design to this. None of them are usually very hard to work on or need any special alignment of gears or anything. They usually find their place easy enough. I could actually push that in by hand now. I better put that plug back in. And I think that wire went through a few of these little bits just to keep it out of the way. Because that basically comes from the main board, and that's just the connections to the two switches and the motor, so the loading motor. So obviously the voltage from the chip that turns that on and off, and the switches will go back to the microprocessor just so it knows when the tray's out or in. And we can just push that back in by hand for now, just to make it easier to get into the machine. And you sit that back on the screw holes. Normally you'd put the screws back in now. I guess I can do that anyway, because hopefully I've had this apart all I need to. So it's just 3 screws, one on either side. I usually put the back one in first, make sure that's lined up. And one on either side. Nice short little screws, which makes it easy. And we can reapply power. Something wasn't fully lined up there. So if it isn't completely loaded or whatever, it's in between somewhere, it'll just find its position because those limit switches won't be in place. And then again, the actual tray door, you just line the 2 little pieces on that. It's got a slot sort of thing in there with a slot on this bit. Just fit them so they're starting to go down the slot. And then you just push it home and it'll click back under. It'll bend out a bit as it goes down and then go back under. Okay, so if I put a disc in here, kind of get used to some of the sounds these things make. It should basically fairly instantly read it. It's only if there's not a disc in there. You can sort of hear the laser go tuk tuk tuk. And if we have a look at that, obviously not get my eyes anywhere near it, so I'll duck out of the way. When I have to open and reclose it, you'll see that laser lens going up and down quite a bit, hunting. So that's always a sign that the thing's working. Like I say, you can actually wind this out a bit and just make sure that heads back in. This one doesn't do a little test thing, sometimes they do, but they should at least slide back to the center, and then immediately the laser should start going up and down. I don't know if I'll be able to get the camera to catch the actual laser lighting up. It's quite hard to see. I can't actually see it on this one very easily, but like I say, it's very rare you need to even check that, because normally the laser will light up, and you'll know as soon if the laser's definitely working if it tries to spin the disc. And then of course the next thing should be that it should come up with a table of contents. Oops, something loose in there. Oops, bit of broken plastic or something. Not surprising, I guess. But anyway, you should come up with the table of contents. Should be the first thing. Oops, this didn't come out. It doesn't like working on that angle. So I'm going to put the disc in. It should spin up and give you the table of contents. Most of them will get at least that far, assuming the belt isn't damaged and the cassette thing, assuming the belt isn't damaged and the tray can slide in properly. If the tray reaches its end and the laser's lifted up, then you should certainly get the laser hunting. It should return to the center if you move it out just to make sure, and then the laser should start searching for a disc. Most of them you'll find they'll at least get to the point of reading the table of contents, but sometimes they'll make a sort of noise like that. And if you give them a spin, they'll actually get going, although this one won't now because I've delayed it. But if they sound something like that, That can either be a bad laser or it can just be the adjustments. And giving it a bit of a spin should get it. You should hear it wind up to that particular sound they tend to make. Almost like a weird sort of scraping sound or something. It's quite a weird noise. And then you'll hear that sort of, I'm not sure if they're braking the motor or what, but it'll make that funny noise as it slows down again. You can hear it wind back down, so they must be doing something. I don't think it's the laser making that noise, I think it's the actual spin motor. But they do make some rather weird noises. Some of it can be the coils in the laser. Sometimes they'll make quite a clicking sound when they lose focus. Some lasers are noisier than others. Guess we can try this one if we go out a bit on the tracks. And you hear that sort of noise as the tracking motor goes a bit. Once you tell it to play, it hunts, it moves in the disc a bit further, hunting for the first track. And you get that sort of whine, zoop, zoop noise as we change tracks. And if I hit it really hard, you sort of hear that click, which is a laser sort of. And that noise is the laser sort of hunting. It may focus and go click, 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 and then the motor will try and fire up. So that sort of click sound, I think, is the laser resetting. So you do get used to the sort of noises these things make, and you can tell a bit of their performance from those noises. But it should at least read the table of contents, give you a list of how many tracks and the time. It's often from there on in that we have trouble with the thing actually tracking. But because the disc starts at the centre and goes out to the outside, it's always the last tracks are the ones you want to test them on. So if you get to the highest numbered track, which is track 20 on this disc, you'll notice that it's making a little bit of noise there, because the laser is now at the most eccentric part of the disc, so probably both that way and up and down. So the laser's got to do more work to actually follow it, so it tends to make a little bit of a clicking noise or scraping noise. And also this motor's slowed down quite a lot compared to the beginning. Go right back to the beginning. That's running pretty fast there. You can probably see on the camera going backwards a bit. Oh, it looks like it's going backwards, and then as you get there, yeah, now it's actually sort of looks like it's going forward, at least in the viewfinder, because it's slowed down quite a bit. For some reason when things speed up, they actually, under the 50 Hz light or whatever, they get to a point where they look still and then they start going backwards. But I don't think I've ever had any trouble with speed issues or anything. It's just the motors causing vibrations or whatever and causing poor tracking. Again, this, you want to check these clamps and stuff aren't too eccentric and wobbling around. Another thing that's very useful, which I've pinched out of the other CD player I got here, is because I've lost my old one, but I always had one of these magnets, ring magnet, which I've stolen out of a CD player clamp, because a lot of these have magnets in them. And if you ever want to work on one of these mechanisms sort of out on their own, you can basically just stick the disc on there, pop your magnet on, because these spin up quite fast, so if the disc has no magnet on it, no clamp, it'll slip. You'll hear a sort of funny sort of sound, and the disc won't go as fast as the motor. Basically, it'll sort of make a rattling sound or something, and that'll be because the spindle's spinning, but the disc isn't stuck to it, so it can't actually grip it, so it slides underneath it, and it won't be able to read the data off the disc because it can't get it up to the right speed. They seem to have something in these, I think, that so they know if the disc slips or if it stops, it's not getting the data at the correct rate, and it'll abandon the disc, usually go back to the center and stop and say error or some sort of thing like that. No disc, that sort of setting, that sort of display. So if you put one of these on, again, you want to keep that magnet as with the least eccentricity as possible, but sometimes a little bit doesn't hurt because it's good to test the thing with that. But if it's off to the center too much like that, any CD player is going to have a bit of trouble reading the end of the disc, because that'll add a bit more wobble into it. But they're a handy little device to have worth pinching out of an old CD player. The sort of round magnets, which are a lot thicker, off like a 57mm speaker, will work on them, but they're not as good. They often got glue and stuff, and they don't sit down as well, and because they're thicker and heavier, they're not as good as these little thin proper ones that were made for the CD players. But they're something always handy to have. I used to have one, I think, stuck to the inside of my toolbox lid, so I could always find it. But of course that was a long time ago now, so I don't know where that's gone. I'm sure I stuck it to the side of the shed here somewhere or something, but I can't find it. So I've just borrowed that one out of the TAC player. I'll have to put that back later, since that things will be going again. But that's about all there is in the main thing. Normally power supply and stuff in these is pretty reliable, but it's always something you could get problems with, dry joints or something. But most of these run very cool. There's no sign of browning on the board or anything. You will find one of these little chips somewhere with the older lasers that have older mechanisms. The circuit board on those would have a separate connector for, like this one here. This is actually a PS1 PlayStation, and that's got a connector for the two motors. This has got one of these little flat motors with a worm wheel to do the sled, and it has a different connector for the laser. Those earlier ones, like I said, they had two connections. I think one was for all the laser coils, and the other one was for the signal coming off the photodiodes, but generally you don't need to know what they are. But wherever that, if it's got a separate motor connector, wherever that goes back to the board, you'll find a sort of driver chip, which then gets its signal from one of these sort of postage stamp type chips normally, or a great big chip that does the servo, and then there'll be a motor driver chip which does the higher current side of things to run the motor. Then they can fail, and you'll basically get the motors that won't reset back to the center, or it won't spin up or something. Usually neither, because usually they're all in the one IC, and usually it's only an over voltage situation or something will kill one of those. They're normally super reliable. All the signal processing stuff super reliable. There's always possible a crystal or something could fail. If there's no audio, it'll be somewhere in one of these little buffer chips or the digital to audio converter. Very rare you get any problems in the audio or the electronics unless it's been over voltaged or some sort of power surge, lightning strike, someone doing something nasty with the audio sockets, putting voltage into them or something. Even then it's probably got capacitors coupling that. Maybe, you know, moisture getting on the board or the board being broken or something, but very rare. I don't know if I've ever had to fix, besides the one unit that had been over voltage, set to 110 volts and plugged into 240, that blew the motor driver chip, one of these sort of flat 16 pin type things. Other than that, I don't think I've ever had to fix electronics on a CD player board. They're normally super reliable, even the power section and stuff. So you generally don't have to do anything with that. It's always this mechanism part or adjustments on the board just to get the laser running again, which again there's not much on this one to look at. I just wonder if it has an RF. It's got all sorts of things here. Most of these links in these Sonys are actually labelled. It doesn't actually tell you what the sections, the ICs do. It's got in switch, out switch, so that'll be those little two switches next to the motor there. This will be the lines coming back to the micro, so if you wanted to, it probably goes from 5 volt to 0 volt, depending if the switch is open or closed. So I guess they've at least labelled them and put a couple of links in, which they may have needed anyway. So if you have loading problems, and it's almost always the belt, but if you did have some other issue, you could at least check those signals to see if the microprocessors, if the switches are feeding back to the micro. But again, always super reliable, those things, but not impossible. The switches could get bad contacts or something, or broken contacts. Got a few things like minus 30 volts, 5 volts, DFCT switch, maybe, whatever that is. That could be something to do with the centering of the laser. Got a mute line. Oh, actually we've got RF clock or something there. PL clock, don't know. And they've labelled a few voltages conveniently for us. But again, I don't think I've ever had a power supply problem. Some of the early Philips players and that, some of the caps are going in them and things, but they were the real early with a die-cast chassis type, die-cast trays and everything in them. But there wouldn't be too many of those still going anymore probably. Most of them are these later ones with a simple little mechanism, fairly small circuit board. They get a lot smaller. Even DVD players and stuff, they're a tiny little board. Probably not a lot more than what this Sony mech has on it. Some of these Sonys I don't think had much more. They made little half-size units of these. to sit on top of like shelf systems, and they had hardly any electronics in them at all. The only other stuff is the stuff to run the display board and the buttons. You might get dry joints or something if people have been hammering on the buttons a bit, or generally, you know, if it's been moved around by a DJ or musician or something that takes their player with them to gigs or something and bangs it around. Not that many people use CD for anything now. I guess the headphone socket or whatever that is, it is phones, that could get problems. And yeah, just some of the buttons and stuff, even if they don't get dry joints on them, they might get some sort of problems with the actual switch contacts themselves. But other than that, yeah, very reliable. It's always messing around with these parts, either cleaning, lubing, and then aligning the main board is probably the main thing you do. Sometimes the spin motor, and yeah, sometimes the laser needs replacing. They do tend to just wear out with time, I think. I mean, they do many hours of running, and being a reasonably high power device, I guess the emission on the laser gets lower or something. That's why you can tweak the little pot and make it a bit brighter, but that'll probably make it wear out even quicker, but you might get a few more years out of the unit, especially if you can't get a new laser easily, or second-hand one even. Problem with second-hand ones, you don't know how many hours they've done. So a high hour second-hand one's probably not going to be any better than one you got. But if you can find a low hours deck in something, but again the problem is there's quite a few different versions of these KSS things. Unless it's the same model or similar age, it's probably going to be a completely different one. And yeah, I'm not sure, I'll have to check if you can still get them as spare parts. Some of these motors, if you can still get them as spares, I reckon they're still available, the motors at least. A lot of these gears varied between the mechanisms, so that could be a problem if they've got broken teeth on them. If they've just got muck in the teeth, you can just sort of scrape it out with a fine screwdriver or the like, and then just clean all the grease off and stuff and get rid of any muck in there, and then re-grease it. But that's about it for these really. I'll have a look at a couple of actual players, and I've got, like I say, an old TIAC one which are common. They always played pretty bad, they were never a very good unit, and that'll I've actually gone through and tweaked that one up, so there'll be a video on a bit of alignment, just using a bad disc and a few taps on the thing and a bit of tweaking. And I guess I should really get one of these out and have a look at the eye pattern. I don't know if I've got any other more players there, but if I can find another one, I might even just try and do it with the eye pattern. But I found that system didn't work very well, and it was easier just to tweak them on a bad disc to get them to play that, and they'd normally go well after that. So that's probably about it for this video, so I'll catch you on the next one.